Okay, so let's continue working here, right? Answer some questions for the exam 5 and final. So, which of the following substances has the highest boiling point? For this one here, let's check which one has the strongest intermolecular forces, right? This one has only the special forces, the same here. And in that case here, water has hydrogen bonding, right? Hydrogen bond is when you have hydrogen, the intermolecular force, when you have a hydrogen with fluorine, oxygen, or nitrogen. So the answer here is water. So which molecule has hydrogen bonding as a predominant thermomolecular forces? So we are going to look for the same thing. Which one will have hydrogen with fluorine, hydrogen with oxygen, or hydrogen with nitrogen? The answer here would be letter C, right? Are you seeing here? OH, hydrogen with oxygen. So the answer is C. Okay. In that case here, which species has London special forces as the only intermolecular forces? So first you need to understand that all molecule, right, they'll have London special forces. But the question is, which species here has London dispersion forces as the only intermolecular force? So calcium bromide, right? We know it's the answer because this one here, you can see there's a dipole. And that dipole here. And actually, we know that this has ionic bonding as intermolecular forces. And here we have, this is also dipole. We have here, there's a polar, these both are polar substances here, right? Now, ethanol here, you have OH. And OH is what? Hydrogen bond, right? So you know that it's not the answer C. Okay, so in that case here, you have carbon with fluorine, hydrogen, right? And you know the bonding between carbon and fluorine is a polar bonding, right? We have electronegativity above, difference above 0.5. So it was here at the chart, right? 2.5 and fluorine 4. 4 minus 2.5, you have 1.5. So it's a polar covalent bond that makes this dipole here. So the only one that has only London special forces is this one. Like if you see the difference between carbon and hydrogen here, will be below 0.5, the electronegativity difference. Okay, so then here, what's the physical state in which matter has a specific volume but does not have a specific shape? So you know that gas has no specific shape and no specific volume, right? So it's not gas. For solid, you know that solid has specific volume and specific shape. So it's not solid. So the answer should be liquid, right? Liquid has specific volume, but not specific shape. That means that the shape can change, but the volume is fixed. So now here, a small amount of salt dissolved in water is an example of a homogeneous mixture, heterogeneous mixture, compound, pure substance, or solid. So salt, if you dissolve salt in water, you are going to see, this is a mixture, right? Salt plus water is a mixture. And when everything dissolved, we can see just one thing through, right? So if you are seeing just one thing through, the answer is homogeneous. It will be heterogeneous if, like, for example, if you mix water and you add here like oil, right? You can see the water and the oil difference, right? So for that case, between water and oil, we have a heterogeneous. And when you see everything, just one is homogeneous. Now, question 41. Calcium reacts with a certain element to form a compound with the general formula calcium X. So what will be the most likely formula for the compound formed between potassium and element X? Okay, so calcium, but this one here, right? Calcium and X. Calcium is a 2+ element, right? And in here, the X, you just have one calcium and one X. So what's gonna be the charge for X here? So remember, the total here should be what? The net charge of the compound should be 0, right? So which number here, which charge will be for X here? Will be a 2 minus, right? 2 plus 2 minus 2, 0. So you know now that X is a 2 minus element, right? Now let's see, let's answer that case here. What would be most likely formula for the compound formed between potassium and element X? Okay, now we have potassium and X. So we already know that X is the same X here, right? So we're gonna be what? A 2 minus element. So potassium is a group 1, the periodic table, so the charge is gonna be 1 minus, oh, sorry, 1 plus. And the net charge should be 0, right? So how many potassium should you have in here? So if your X is minus 2, how many plus should you have in here? Should you have it 2, right? To be 2 minus 2, 0. So that means you need 2 potassiums to make 2 times 1, 2. So 2 minus 2, 0. So the answer is B. Right? Now the next one here. Question about formula charge. What's the formula charge? Formula charge is equal what? Valence electrons minus lone electrons, right? Minus half of bonded electrons. Now, there's a structure here, right? What will be a formula charge for each atom here? Let's find it for chlorine first here. Chlorine. How many valence electrons we have for chlorine? Chlorine here, group 7, family 7A, so 7 valence electrons. How many lone electrons here? 1, 2, 3, 4. So 7 minus 4 minus the half of a bonded electron. So here you have each line, you count as 2 electrons, right? 2 electrons. So 1, 2, 3, 4. So you have 4 bonded electrons divided by 2, it will be 2. That it means here, the formula charge for chlorine will be 7 minus 6 will be plus 1, right? Now let's calculate the formula chart for oxygen. Both oxygens, they are the same way, right? Just 1 bonded and 6 lone electrons. So just need to do oxygen just once here. Oxygen is valence electrons. We'll put here 6A, family 6A, so 6 valence electrons, minus how many lone electrons here? 1, 2, 3, 4, 5, 6, minus what? Minus 6 valence electrons. Then minus the half of a bonded electron. So here you have 2 electrons divided by 2, so it will be minus 1. So 6 minus 6 minus 1, the answer is minus 1. So the answer is going to be plus 1 for chlorine and minus 1 for each oxygen. So the answer is A. So now this one is about concentration of ions, right? You need to understand that if you have the molarity, but what's the concentration of lithium and phosphate ions? So are you seeing how many lithiums do you have here? You have 3 lithiums, right? And how many phosphate you have here? Only 1. So this question already gave you the molarity of the solution. So we're going to multiply 2.3 moles per liter times 3, because to find the molarity of lithium, we're going to multiply the molarity given by 3. So 2.23 times 3, it's shown here. The same thing for phosphate. Phosphate will have only 1, because phosphate is this polyatomic ion here. And you have only 1 phosphate in this molecule, in this compound here. So 2.23 times 1 will be 2.23 moles. For question 43 here, already answered this one, right? The value of enthalpy change for the reaction below is minus 6,535 kilojoules. So the question is, what's the kilojoules of heat are released in the combustion of 16 grams of C6H6? Okay, so the first thing, let's start with what was given here. 16 grams of this one. Then convert from grams to moles, right? We're going to divide by the molar mass. So 80 grams here is the molar mass of C6H6. And then you multiply by the enthalpy change for the reaction. divided by the moles of CH86 in the reaction that was given here, that the balanced reaction. Have 2 moles, so 2 moles. So just let's return here. First, convert from grams to moles here, right? Then you multiply by the enthalpy change given and divide by the moles of the C6H6 that is in the reaction here, the balanced chemical reaction. Then you find your answer here. Then in other words, like this one, minus 605 kilojoules. So 82 moles here, right? 2 moles of this reaction releases the amount of the heat. So then the question is going to be, okay, now convert from grams to moles and then multiply by the heat divided by the moles of the reaction here. Okay, there's another reaction. Oh, sorry, there's another question. It's already answered here. So if this is about gases here, chapter 10, right? If an NGO plus T balloon has a volume of 0.85 cubic centimeter and it contains an inert gas mixture at 0.95 atm at room temperature of 20 degrees Celsius, what's the result pressure of the balloons if the temperature increases to 37 degrees Celsius and the volume is reduced to 0.50 cubic centimeter? So you needed to remember that the cubic centimeter is the same as milliliters. So let's say what you have. Initial volume. Volume 1 was 0.85 cubic centimeter. That's equal to 0.85 milliliters, right? 0.85 here. Now let's talk about V2. The final volume here was 0.50 cubic centimeter. This is equal to 0.50 milliliters. Okay, and then if Angioplas's balloon has a volume, this initial volume, and it contains an inert gas mixture at 0.95 atm, so we have the initial pressure here, 0.95 atm, at room temperature, what is the resulting pressure if the balloon if the temperature is increased to 37? So here, the question is asking for the final pressure, right? And you have also the T still changing here. Already voted here. So 20, what is it? So 20 degrees Celsius, Kelvin, will be 293 Kelvin. And 37 Celsius to Kelvin going to be 310 Kelvin. So now you are going to use it. Initially, the combined law will be P1, V1, N1, T1 equal P2, V2, N2, T2. So let's cancel out what do not need. The question is talking about pressure. Yes, right? Actually, the question is asking about P2. The question gives different volumes for volume. Yes, have initial volume and final volume. So cannot cancel out the volume. Temperature, yes, we have two temperature change. So the only thing the question is not talking is small number. So if you have a variable that is not talking about, or if it's not a change, then you can cancel out. Then we are going to solve for P2 to rearrange it here, right? And should define this answer here. So P2 would be what? Would be P1, V1, T2 divided by T1, V2. And you should get this answer here. Remember that for this one, you need to convert it to liters, right? How do you convert from milliliters to liters? You divide it by 1,000, okay? So we also needed to talk about the gases. We also need to practice ideal gas law equation, PV equal nRT, right? But in that case here, you use the combined equation. So 46, as electron moves closer to a nucleus, energy will be released. So we have here let's say the electron here, right? And if the electron jumps to a higher further from the nucleus, energy will be absorbing energy. But when the electron is returning, that means moving closer to the nucleus, energy is released. Right? Then oxidation is what? Oil, right? Let's remember oil. Oxidation is loss, reduction is gain. So which will be the answer here? Oxidation is loss of electrons and reduction is gain of electrons. So the BC here. So this question here is about Hess law, right? That you need to manage these three equations to find this one, to find what's the enthalpy here for this reaction. So this is the global reaction. We needed to move it, these three reactions here to make multiply by 2, multiply by -1. Let's see what we need to do here. So carbon, oxygen, producing CO2. Let's look for this reaction here. This reaction here, we have oxygen in the reactant, okay, and carbon dioxide in the product. Okay, so for now, let's not do anything here because the reaction is the same as the speeds at the same position as they are in the global reaction. Now let's look for the second one. The second one will have sulfur, oxygen, and sulfur dioxide. And here we have sulfur dioxide in the reactant, sorry, in the product side. This one is also in the product side, right? But what's the difference between this to this one? Here you have only 1 mole sulfur dioxide, and here you have 2 moles of sulfur dioxide. So let's multiply this equation by 2. If you multiply by 2, you have 2, 2, and 2. And we also need to multiply what? The enthalpy change. Now let's look for the last one. The last one, we have carbon, but you don't need it, do not need carbon here. The same thing, this carbon here, do not need it. 2 sulfur, we do not need the sulfur either. But here you have the carbon sulfide here, right? And here is in the product, but here is in the reactant side. That means you need to flip this equation. How to flip it? You multiply by -1. So multiply by -1. So the products will become reactants. Right? Carbon plus 2s. And the hue changes to negative, right? So now let's see if you are doing okay here. Now let's cancel out what is this. If you have a species, the same species in opposite position, like if one is in the reactant and another is the product, then you can cancel out. Now let's check here. Carbon solid here is in the reactant, in the reaction 3. So remember, you cancel out this reaction, right? Because you flip already. So we can cancel out carbon with carbon. What else? Two sulfur with 2 sulfur, right? And now you have oxygen, you need oxygen here, you need carbon dioxide here, and you need the 2 sulfur dioxide. So that means now let's adapt this. So let's write it here. Copper, copper carbon plus non-reactant. We have this 2 as reactant right here. 2 plus 1, 3 oxygens, right? And then sulfur dioxide, we have a 2 sulfur dioxide plus 1 carbon dioxide. So let's check if the reaction is the same. Yes, the same reactant, the same products. Now let's do the math here. So gonna be minus 393.5. So multiply this by 2 here, right? 2 times minus 296.8. Right? Plus, that can be minus, right? Minus 87.9. Okay, then you can do the calculation here. So for question 49, calculate the enthalpy change, the energy here, thermal energy change of a gas that in which the gas evolves 12 joules of heat and it does 8 joules, 12 joules of heat and does 8 joules of work by expanding. So evolves 12, right? That means it's releasing 12. So minus 12, the energy here. Does, if it does, that means it's expanding, right? So minus 8, then it should be minus 20 joules here, right? Okay. Now question 50 is about the molarity. What's the molar concentration of potassium bromide in a solution prepared by dissolving 357 grams of potassium bromide in 1850 milliliters of aqueous solution? So this is the aqueous solution. So the volume of the solution already, right? Solution is the total. What's the solution? Solution is solute plus solvent, right? So the volume of the solution is 1850 milliliter. We need to convert to liter. It's gonna be 8.150 liter, right? Okay, then what's the formula for molarity? Molarity is equal moles of the solute, right? Divide the volume of the solution in liter. That's already here. In other words, you just need to find what? the moles. 3.57. So moles will be 3.57 divided by 119.02 grams per mole. Right? Then, after find the moles here, we're going to divide these moles by 0.850 liters. And then you have your answer to be molar, capitalize M or mole per liter. Okay, so how many grams of magnesium oxide are produced when 15 grams of oxygen react completely with magnesium? So the first thing, let's balance it. Is the reaction balanced here? No, right? So we have 2 oxygen, so we need to have 2. Let's add 2. So when we add the 2, you also change the number of magnesium. So let's add a 2 here. Okay, so this is the balanced chemical equation. Now let's start with what was given. So 15 grams of oxygen, right? Each 1 mole of oxygen was the molar mass. So remember, from grams to moles divided by the molar mass. Each oxygen is 16 here, right? So times 2, 32 grams per mole. Now let's use the stoichiometry ratio to convert the moles of oxygen to moles of magnesium. So we have 1 mole of O2 here and 2 moles of magnesium oxide. Oops, let me write moles here. So now this step here is from grams to moles, right? This step here is from moles of one substance to another. So from moles of O2 to moles of magnesium oxide. Then you need to convert it from moles to grams, you multiply by the molar mass. What's the molar mass of magnesium oxide? So magnesium is 24.3, oxygen is 16, so we're gonna be around 40.3 grams, right, of magnesium oxide. So each 1 mole magnesium have this amount in grams. And you are done here, your answer should be in grams of magnesium oxide. So you can see, right, cancel here. Grams with grams, moles with moles, moles of magnesium with moles of magnesium. So your answer will be in grams of magnesium oxide. So look at the steps here. First, from grams to moles. So divide, take the mass, divide by the molar mass. Now, to convert the moles of one substance to another, you are going to use the mole ratio. That's from the chemical reaction. So after you have the moles of the second substance, you are going to multiply the moles by the molar mass to convert it from moles to grams. And then you are done with question 51. All right. So the question 52, what volume in liters of carbon dioxide is produced when 2.50 kilograms of potassium carbonate decomposes at 25 degrees Celsius in 1.15 atm here, right? So you need the reaction first. So I'm gonna write potassium carbonate and potassium oxide plus carbon dioxide. So two potassium, one carbon, three oxygens, 1 plus 2, 3 oxygens, right? So now let's convert the amount of potassium carbonate from grams to moles. So first you have in kilograms. So kilograms, each kilogram, right? So each 1 kilogram, you have 1,000 grams. So here you have converted gonna be 2,050 grams potassium carbonate. Then after you have the grams, you are going to convert from grams to moles. Take 1 mole. What's the molar mass of potassium carbonate? Is 138.2 grams per mole. So how many moles we'll have here? Find this number of moles. And then the question is asking, what's the volume in liters? So you are going to use the ideal gas law, PV equal nRT. So before volume, right? The question is asking for volume. So volume is equal mole number RT divided by pressure. Remember, what need to change here? So moles was what to calculate right here. R is the universal gas constant, 0.08206 liters atm per mole Kelvin, right? Now let's go. Temperature should be Kelvin, so 25 plus 273 would be 298 Kelvin. Temperature should be in Kelvin. Any pressure is already in 1.15. So what we're gonna do here, take the small number calculated here, multiply by R, the universal gas constant, multiplied by T, that's your 298, divided by your pressure. And your answer should be already in liters, right? Okay, let's this one for practice this one for you to draw the diagram of simple substance, like you can do like water, the pressure temperature plane for water, and what the contribution of the Dalton make to atomic theory. Let's see what we can learn some more. I'm gonna stop it here for now, and then I'm gonna do the another one. Another video.